this first picture is, I think, really emblematic of what I'm talking about, in that, you see cows here, right? You don't see bobolinks, but in fact, in this picture is actually has a number of bobolinks in it, but there are females that are sitting on nests, and the nests are totally buried. They're on the ground, but the cows are there to maintain the habitats. So this is the region that I have largely focused on. I've only recently started working on the refuge, and I'll show you some of that data in a little bit. This is a picture of the central Champlain Valley, looking west towards the Adirondacks. And this is a really typical landscape to all of you, right? Where you have farms spread out. And importantly, across this landscape, you have lots of different landowners doing lots of different things. And so the good thing about that is that it keeps agriculture in the landscape. And the challenging thing about that is that when you're trying to do conservation work, you have to work with every single one of those landowners, as compared to working, let's say, in the Midwest or the West, where you could work on a single farm that's 10,000 acres. Here in the Champlain Valley, 10,000 acres could be, 100 different landowners or 80 different landowners, who knows? So that really complicates things. And our work has been really basic biology, where we have a group of fields where we try to understand everything there is to know about these birds on these fields. So we really focus on bobolinks and savanna sparrows, because they're the two most abundant grassland bird species nesting in these fields. There are some others, meadowlarks occasionally, grasshopper sparrows, but they're few and far between. And our job is really focusing on their demographics. We want to know who all the birds are on each field. And then we want to know everything there is to know about them. We want to know when they nest, where they nest, what's the characteristics of that nest, meaning how many eggs and chicks do they have? Do the nests fledge or fail? And then we want to know who they nest with. And so we identify their mates. And in the bottom center picture, you can see a bobolink hanging in a mist net, and that's how we catch these birds. And these birds have bands on their legs, and the bands on their legs let us identify who they are as individuals. And then importantly, on the bottom left and right, we band their chicks, and their chicks get a single metal band. And one of the reasons this project has continued for so long is that a huge number of these birds that we band as chicks come back to breed locally on our study fields or within 3 kilometers, so really close nearby. And this has enabled us to essentially study genealogies of birds that have gone back up to 7 generations, which is really unusual field data for a migratory species that are nesting in the continent compared to islands. And we've collected a lot of data. So over this time period, we've banded over 10,000 birds, and we've monitored just short of 4,000 nests. So there's a lot of really great information that we've collected, and we can ask about these animals. So I'm going to talk very briefly about management, and that is because, and this just in a couple of short slides, in that the project started as a question about management. And we found that if any field is hayed by June 11th, there's 100% nest failure. And it's really rough to watch, but that's the reality of it. About 80% of the nests get destroyed by the machinery, and about 20% of the nests survive intact, but those are all eaten by scavengers, things like gulls or ravens or mammals like raccoons and possums and so forth. So that's pretty rough on these birds. But within the context of that, it's important to ask, well, if that's only happening on a small percent of the habitat in the Champlain Valley, then maybe that's not too important to the populations. But in fact, it's happening on up to 50% of the habitat every year, and that number is actually higher. These are a bit old data. So early haying is happening across the whole Champlain Valley, and it's really the main driver of what happens to these birds. So as a result of that information, we really wanted to work on trying to create management plans for farmers that are different than the dogma. And the dogma was really established in the late 1990s by a really outstanding project done by Mass Audubon, where they were really encouraging folks to delay their hay harvest, and that was the best for the birds. And that's true. And I in no way am contradicting that. However, that is a non-starter for dairy farmers. They simply cannot delay their hay harvests into July or August. They need to cut early for the quality of the forage. And so our goal was instead to say, let's try to get everybody to delay. Let's think and see if we can come up with a model that works for dairy farmers where they can still mow what they need to mow and balance for birds. And we came up with a model that really works. And the model is very simple in that we want farmers actually to mow as absolutely early in the season, in May as possible, absolutely as early in May as possible. If you can mow on May 15th, do it. If you can mow on the 20th, do it. Even like the 22nd, 23rd, that's great. Because that's early enough where the birds have either started nesting but put very little investment into the nest, or they haven't even started nesting yet. So then the fields are mowed. And then we ask, after the fields are mowed, we ask farmers to delay the second harvest for 65 days. Typically, the fields would be reharvested between 35 and 40 days. And so we're asking for farmers to basically delay that second harvest for 20 or 25 days. And we've gone out and we've monitored this model. And this is the data. So this is on the y-axis is the number of babies that a female can produce in a year, from 0 to 6. And on their far right, in the red, is the number of babies that are on a traditional early hayed field where the farmer cuts early and then cuts again 35 or 40 days. And in that model, in the red, you can see that bobolinks produce 0 offspring, and savanna sparrows produce just over 1 offspring on average per female per year. So not a sustainable situation, especially if that's over 50% of our habitat. So we created this model that you see in the yellow bars that I just described to you, and it had absolutely dramatic effects on reproductive success, where savanna sparrows produced twice the number of offspring that they did, and bobolinks went from producing 0 offspring to producing just under 3 offspring per female per year. Really, really dramatic increase. The blue bars in the middle is what these birds do on fields that are never cut at all, or not cut during the breeding season. And they're not statistically different, where bobolinks are not producing statistically more offspring on fields that are not harvested as they are in this program. So this is a real win for us and real conservation success, and it's been used a lot in many different places. I'm happy to talk more about this model later during questions if folks have questions about it, but I want to move on to tell you some different stories about the birds' lives themselves and really why these birds are so special. And the story starts truly with this image here, in that this is many, but not all of the students that have worked with me across the last, what feels like a zillion years, out studying these birds, blood, sweat, and tears, early mornings. And they bring amazing spirit to it. And quickly, I'm going to show you 3 projects that I worked with some of these students that have really fascinating outcomes. First, let's talk about divorce. Yeah, that's right. Who thought you'd come here to learn about divorce and birds? So I had a student who's from Vermont, actually, and from northern Vermont, work on the project. Her name was Kylie DiMaggio. And we were just chatting one day after her first field season working on the project, and we talked about divorce and birds. And she was like, wow, I wonder what that means for these birds. And so what divorce is defined as is there's 2 components to it, is where you have 2 birds that are nesting together, and whatever happens to them. And that nest either is successful or it fails. If they re-nest that year, they have a choice to either re-nest with that same mate or pick another mate. And so that's a choice of divorce right there. And then a second choice of divorce is that pair has their breeding season and they migrate somewhere far away, they both return to the same field and they've both survived. Do they choose to repair with each other? We wanted to know about the consequences of repairing or divorcing between both bobolinks and savanna sparrows. And the results are really interesting. So first, I'm going to tell you about between years. So that's the year going from last year to this year. So almost all bobolinks divorce, period. 85% of them, if divorce, regardless of what happens, they're there. I can't explain that to you right now, but they divorce nonetheless. A majority of savanna sparrow pairs also divorce. Almost 70% of them divorce between years, such as life. The story is very different within a given breeding season. So for bobolinks, we have never documented them divorcing between pairs. I say that with a real cautionary tone in that bobolinks are pretty rare to renest within a given season. Females typically only have one nest, but some do renest. And when they renest, if they stay on the field, they always pair with the same male. Savanna sparrows are pretty similar. 83% of them repaired with the exact same mate as their first or second or third nests. So that's kind of interesting. And now I want to show you the consequence. Does it matter if you divorce or not? All right. So in the left hand of this, again, the figure on the y-axis is the number of babies that they produce in a given year. And savanna sparrows on the left, bobolinks on the right. So let's just first focus on savanna sparrows. In the light gray bars, that's pairs that divorced. And in the gray bars are those ones that did not divorce. And what you're interested in to see is the number, how it changes over time. So the number of fledged in the first nest, how does that compare to the number of fledged in the renest? And for savanna sparrows, the number doesn't change whether they divorce or not divorce. It's exactly the same. And so as far as producing babies, divorce has no consequence and no benefit to savanna sparrows. For bobolinks, the story is actually quite different. If you look at the bars, the gray bar with the 92s in it for bobolinks, you see that from their first nest to the number of fledged in the renest, they actually produce fewer offspring if they divorce, and they produce more offspring if they do not divorce. And so I think that really explains, why they don't divorce within a given season, in that they're better at making babies. That's really good news. All right, so that's student project number one. Here is student project number two. There's this idea of senescence, and senescence is that humans, it's the same concept, or animals, that their ability to do things biologically changes with age. And in theory, changes mean it declines with age. And we were interested, we've had birds live a very long time. We've had some savanna sparrows and bobolinks live up to 11 years on our study fields. We wanted to know if birds, as they age, do they become better at nesting, or do they have a harder time as they get older? And this is an awesome student named Olivia Scott who looked at this work, and we looked at nest success, daily nest survival. Daily nest survival, it's very easy to explain. If you look on that y-axis, it goes from 0.88 to 1. And so what that means is if it's 1, it means that there's 100% chance that a nest that's active right now is going to survive to tomorrow. And if it's a 0.9, it means that there's a 90% chance that a nest is active now, will survive to tomorrow. So naturally, you want to have highly daily nest survival to be able to produce their young. And remarkably, what we found is that for both species, younger birds, younger females, are better at nesting. They produce, they're better at fledging young. And the curve is especially stronger for savanna sparrows. For savanna sparrows, this doesn't really surprise me too much, because we have some savanna sparrows that can, when they're younger, produce incredible numbers of eggs. We've had young savanna sparrows, meaning in their second or third year, produce 6 clutches of 4 eggs, so up to 24 eggs in a given season, which is just a remarkable energetic effect. So this is something that was really kind of surprising, that these birds really, as they get older, become less successful in their nesting. All right, so the third project I want to show you, I'm going to skip this part here, is about climate change. This was another paper that we published recently with a student named Maeve McGowan. Who's a wonderful, wonderful student. And this map that I'm showing right here is from an original paper that I published with Roz Renfrew, who many of you all might know from, she's a Vermonter there. And that this map shows you the distribution of where bobolinks go across the year. So the what panel on the left is bobolink migration from 5 different breeding populations into South America, where they stop over and where they winter. And then the panel on the right is their movements coming back in the spring, where they go. We wanted to look at the weather that these birds experience across all of their lives in this massive migration, to try to understand if, as the weather is changing with climate change, as the climate is changing, how are the birds responding to this? And especially, are they responding to what they experience in South America in terms of their timing when they get to Vermont? Are they nesting sooner on a really warm year, or how does that work? So what we found, really remarkably, in Vermont were 2 kind of concerning things. One, not concerning, I shouldn't say that. 2 very interesting things. One, bobolinks and savanna sparrows, on the top panel, this shows you the date that the birds started nesting over a 20-year period. And the numbers on the y-axis, it's called the Julian date, that goes from 140 to 152. The Julian date is very simply the number of days since the new year, right? So 140 days since the new year, or 150 days since the new year. And you can see over time, for both species, while there is annual variation within maybe 8 or 10 days of when they start nesting, the long-term trend shows that they are not changing the timing that they nest. They're not nesting later, they're not nesting earlier. They're very consistent when they nest. Now that's important information, but since they're nesting in agricultural fields, we want to know, are farmers responding to climate change? And the panel on the bottom shows you just that. Over the exact same period of time, this is the time where farmers started cutting their hay in Shelburne. And there was a dramatic change. In just a 20-year period, the first hay harvest date advanced by 10 days. 10 days. That is a remarkable change in a very short period of time. And that advance has accelerated for this year. I heard of dairy farmers haying nearby there on May 8th this month, which is remarkably early. And so I'm showing you this today is that now that we know that birds are staying the same, but farmers are cutting earlier, it makes us rethink of what kind of management plans do we need to adapt to in the future to be able to support these birds, because what we talked about 15 years ago might not work in the same way. All right. So those are 3 student projects I wanted to show you. And now I'd like to transition into something quite different and talk about bobolink movements internationally. The first project I want to show you is takes place in collaboration on the Missisquoi National Wildlife Refuge. And we are using this network here that you can see this map of, called the Motus network, which is a project that was started by Birds Canada, in that they put out towers. Each of these yellow dots is a location of a tower. And the tower looks like an old school TV antenna. And when we attach a particular type of device on an animal, a bird, a bat, a butterfly, a dragonfly, and that animal flies within about 15 kilometers of that tower, the tower is able to detect it as it migrates by. And so we're able to let this animal, put a tag on an animal, let it go, and these towers are working 24 hours a day to see if the animal is flying by, okay? And the growth of the number of towers is incredible. I don't know the exact current number because there's literally more and more every week. I last heard there was around 1,200 towers globally, which is really remarkable. So this is what these tags look like. They're called nano tags. And Ken Strom last year bought 10. We came to the refuge and deployed them on bobolinks, 5 on male bobolinks and 5 on female bobolinks. The tags are very small. They weigh about 0.7 grams, I think. And you can see in the left-hand picture in my finger just how tiny they are. They have this long antenna that sticks off the back that beeps every 10 seconds. And these devices can last for about 6 months of migration. So what I'm going to now show you is a series of, I think maybe 6 or 7 or 8 maps of where bobolinks from Missisquoi were detected on their migration. Okay, so this is what all the maps going to look like. They're all black, and each of the dots that you see here are the Motus towers that were available and to potentially detect a bobolink as it's passing by. And then the triangles or diamonds are the towers that did detect this particular bobolink as it was passing by. And all of these detections illustrate the fall migration. And so what you're going to kind of orientate your eyes to is going from the top of the screen down, because the birds are going from the north to the south, okay? And they're all starting in Missisquoi. So this bird, remarkably, was last seen at the Missisquoi Tower on the 12th of September, and then flew directly to Massachusetts, and was detected there 1 day later, and then continued south and was detected 3 days later on the shores of the Chesapeake Bay in Maryland. So a pretty long and a pretty quick movement pattern. In 3 days, it got from Vermont to Maryland on the shores of the Chesapeake Bay. Okay, keep that kind of pattern in mind. This second bird was last detected in late August in Missisquoi. It was then detected on Shelburne Farms, remarkably, in late August, and then took a quick flight from Shelburne Farms directly to New Jersey. And then from New Jersey, it moved directly the next day, again to the Delmarva Peninsula on the shores of the Chesapeake Bay, to a number of towers where it was seen there again in August. So the bird concentrating around the same time in a similar place. Here's a third bird that was last seen in Missisquoi in late August. Flew south, apparently through New York, and then into eastern Pennsylvania, where it was detected for 2 days. And then the bird was no longer noticed. But you can see the general trajectory is fairly consistent with the previous birds. All right, the next bird, last seen in Missisquoi on the 20th of August, moved very quickly down to the Delmarva Peninsula, where it stayed there at least till the 20th of September and foraged along in agricultural fields likely, or in tidal wetlands on the Chesapeake Bay, again in mid-September. Here, this bird was last seen in Missisquoi on August 29th, and then on the 2nd of September, it was found where else? In the Chesapeake Bay, right on the shores of the Delmarva Peninsula. And I think this is the last one to show you. This bird was last seen on 29th of August in Missisquoi, moved south through the Delmarva Peninsula, both sides of the Chesapeake Bay. And then in the first week of September, flew from there and was later detected on the North Carolina border with Virginia, where it was seen on the 20th of September. Okay, so, sorry, I think this is the last one. Here we go. So this bird was kind of wild. This bird, there you see a detection that's up north of Missisquoi. I am not sure that those were real detections. I wouldn't take too much stock into them. So let's focus on going south. This bird could have been exactly like some of the other birds I've shown you, coming south in late August, in early September, into Delmarva Peninsula, and then leaving the Delmarva Peninsula in mid-September. All right. So at this point, I think the trend of this should be very clear with everybody, right? Where the story was effectively the same. No towers really in the southern US detected these birds at all. And so the birds are really coming from northern Vermont and leaving there in late August, getting to the Delmarva Peninsula in September, early September, and spending up to about 2 weeks there. And then from the Delmarva Peninsula, they're going ocean bound and taking a big ocean flight. They're just not being seen in the southern US. All right, so the next tracking study I want to show you is with a different technology. This technology is called geolocators. And geolocators were first published for songbirds with a paper that sort of shook the ornithological world, published by Bridget Stutchberry in 2009 in Science. In that they're little devices that the birds wear, and they wear them like backpacks. And if we deploy one on the bird and let it go and it flies really far away and it comes back, we can then take that device off the next year. And the device has stored information about where it's been. The device reads the light levels of the day, and we can take those light levels and map them geographically of where the bird has been. I've been putting these devices on bobolinks for a long time, and more recently on savanna sparrows. And I want to show you briefly what some of the amazing things we've learned from them are. You can see what they look like on the birds. The figure on the left is a female bobolink. The one in the center is a male bobolink, and then a savanna sparrow on the right. This is a paper I published a few years ago with bobolinks and wanting to focus on their ocean crossing behavior. And remember, previously, it looked really clear that the birds were flying directly from the Delmarva Peninsula, going over the ocean. And if you look at most of these lines here, using geolocators, it looks like a very similar trajectory as well. So in this paper, the vast majority of males and females are white and females are red, took oceanic flights from the mid-Atlantic states or New England, all the way up to Nova Scotia, down to the Caribbean and then South America. Remarkably, in this paper had 20 birds in it. Of these 20 birds, 5 of them flew nonstop from northern North America all the way to Colombia or Venezuela. It took them about 3 days, but they never landed, and they just beat those wings on and on and on all the way down there. It's really incredible stuff. So that's the ocean crossing of these birds. This is the full migration of these birds. The dots that you see, they're not exact positions of where the birds spent. They're regions that the birds spent the winter. And this really illustrates how far south bobolinks that are breeding in Vermont are traveling. You know, some to really deep into Argentina. A seriously remarkable migration. You know, and I mentioned earlier, we've had some bobolinks live up to at least 11 years So you think about these birds doing these migration 22 times, once every spring and then fall as well. It's just mind-bending to me. I sometimes I just can't believe it. These are birds that weigh as much as 2 strawberries. They weigh 30 grams. They're absolutely tiny. So these are some data for savanna sparrows, and this is just 1 year of returns. And this is where savanna sparrows spent their winter. The geolocators aren't as good for savanna sparrows in showing you the migratory path, but they are quite good in showing you where the birds spent most of their winter. And here the red pins are males and the yellow pins are females. And I had to say, when I first made this map, I was just blown away and almost, I don't even know if the word's frustrated or what, by the incredibly huge distribution that savanna sparrows are using. These are all birds that nest on 1 or 2 fields in Shelburne farms. They're coming together, but look how far. They're going all the way from, excuse me, far northwestern Pennsylvania to Arkansas, to Cuba, to South Carolina, in Florida. It's just incredible, the massive distribution that these birds are using when they're not breeding. We have a few more years of data to analyze. This is just the first year of data, and so more to come from these savanna sparrows. And I hope to write some grants to be able to get some more geolocators on these guys, because they're doing some neat stuff. We've got to figure it out. All right. So the last thing I want to show you for this talk is the next frontier of tracking devices. And I've been really lucky to get a special permit to test these tracking devices. This is, as you see, a male bobolink, and he is wearing a tag that communicates with satellites. And so we catch the bird, we put this tag on him, we let him go. We never have to see him again. We never have to recapture him again to take the information off of it. And importantly, it sends real-time data that is very precise. With the geolocators, we could tell you kind of approximately what county the bird is in. With these satellite tags, I can tell you what field the bird is in, which is just a remarkably different type of story, because then it can tell you when the bird's on migration, what sort of habitats it's selecting. So these tags are, they weigh 2 grams, and they transmit consistently to satellites. Here is some of the paths that I want to show you. This is for one particular bobolink. We were able to track it from its breeding grounds in Vermont all the way down to where it first landed in Colombia. Unfortunately, the tag stopped working after it arrived in Colombia, but we were able to get this absolutely incredible migration path. And then the amount of detail and precision is just so different. And let me show you what I mean by that. This is the Delmarva Peninsula. This is the Blackwater National Wildlife Refuge in Maryland. The blue hatched bars are the refuge boundary. And then you can see on the west of the refuge is the Chesapeake Bay. This bird it flew directly to Blackwater National Wildlife Refuge from New York, 344 kilometers. It got there in 12 hours. And it spent a couple weeks there, foraging, fattening up for a big flight. And what's important is that at the same time as this bird was here, we had about 10 bobolinks wearing nanotags that were detected at the tower for Blackwater National Wildlife Refuge. So we know the birds were there, but these tags, unlike the nanotags, can tell us exactly where the birds were using. And remarkably, when you look at the distribution of these dots, more than 90% of this bird's time was spent outside of the refuge in agricultural fields or tidal wetlands, but nearby. And this information, I think, is incredibly informative to the refuge managers, and that it just shows how important it is for them to think about what habitats are adjacent to their properties and how are they being managed, and can we work with farmers to balance farming needs and birds needs. And maybe the farmers are doing everything perfectly, they're creating the timing of habitat perfectly, and so that information is important. Say, hey, don't change anything, you're nailing it, the birds are loving it, it's great, do what you're doing. And this kind of satellite information can really tell you that level of detail. So from the Missisquoi National Wildlife Refuge, this bird flew nonstop to Cuba. And here in Cuba, the bird also went to agricultural fields. It took 2 days, exactly. It flew for 47 hours, 1,900 kilometers to arrive in Cuba, where it spent just shy of 3 days feeding in agricultural fields. And you can see here on the top right of this image, there's a circle kind of in the natural habitat. That's created by an irrigation system. And these birds were foraging. I connected with a local ornithologist to find out exactly what types of agricultural habitats this were. And it turns out the bird was feeding in corn, bean, and plantain fields in Cuba. So really important information. And that information is of special importance because shortly after I got these data, a big article came out in National Geographic regarding the kind of COVID and post-COVID rates of illegal bird trapping that's happening in Cuba. And they've gone absolutely bananas. The amount of illegal bird trapping has really increased in the last few years there. And in fact, this ornithologist that helped me figure out the habitat types here had fairly recently seen 30 bobolinks trapped in a cage and being sold in a black market. It's completely illegal in Cuba. The government forbids it, but it's happening. And so this really gives us a lot of information to think about. Well, okay, in Vermont, we're talking about haying, and that's important. And in Venezuela, we talk a lot about things relative to chemicals being put in agricultural fields. But in Cuba, now we know we need to think a lot about trapping and how is that affecting these species populations. So really, these satellite tags are just changing our ability to understand what these birds are doing and when they're doing them. All right, so that's the end of my talk. I do want to, before I wrap things up, I want to thank my amazing collaborators who work on all components of this. Alan Strong, who many of you may know at the University of Vermont, he was my PhD advisor and has been a mentor of mine for a long time. Two of my former grad students, Jenna Cava and Emma White, Steve Travis, who I collaborate with at my university on molecular work, Will Kuchitsky, who I also collaborate with on GIS work, and then Roz Renfrew, who has been a longtime collaborator. She's in Vermont on all things Bobolink. Huge number of funders I want to thank. Thank you to Ken for supporting the nano tags. We'll be there again pretty soon to put on 10 more nano tags this summer, which is super exciting. And then the most important thing to thank are these little baby Savannah sparrows, because they're just the most adorable things ever. And such a joy to spend time with. All right, so with that, I'm going to stop sharing my screen. And if there are questions, I would be happy to answer any questions that you may have.
So while people type some in, I'm sure there's some questions out there. I have a question. Are these satellite tags, what did you refer to them? What are they called?
We can do satellite tags works. Yeah.
Satellite tags works. Okay. What is the cost of one of those satellite tags?
Yeah, they cost $2,000, and
wow.
And then for every month that they operate, you pay like a cell phone bill. They cost $75 per tag to get the data from the satellites.
Wow.
Yeah, so they're expensive. And satellite tags have been available for birds for a long time, but they've been available to put on big birds, raptors, ducks, shorebirds. They have not been available to put on small birds. In fact, so bobolinks weigh 30 grams. The closest bird in the literature that's been used is a nighthawks, which weigh over 70 grams. And so this is a major, what I'm showing you, the data I showed you today is a really major miniaturization. To be able to go from a bird that's 70 to 80 grams to a bird that's 30 grams is a huge change in technology.
So they're constructing the tags so that they're small enough to place on songbirds then?
Yeah.
Okay.
That's right.
And how long do they last for?
Indefinite. They're
batteries?
They don't have they have solar panels, and so they transmit for as long as the bird's alive, or as long as the tag's not destroyed. They have the potential to transmit effectively indefinitely. We'll see. I haven't yet gotten a full cycle, migration cycle, but I've had 4 birds make it to South America with the tags on.
Wow. So Emily asks, it seems like so many of your tagged birds, among others, are using the Delmarva. Is there talk of having a bunch of birding volunteers go out during migration to see if they can find the color bands and read them?
Yeah, that would be amazing. We have not talked about that, but that's, I think, a great idea. Maybe a great way to get involved with the refuge, the Blackwater, an equivalent to your friends group there, to round up some volunteers, or a local Audubon chapter. That'd be a great idea.
So any other questions for Noah?
So I see there's a few in the chat here. One, how do I communicate with farmers and best hang schedules? So I communicate with farmers in a couple different ways. The first way is through the Natural Resource Conservation Service, NRCS, which is a federal agency that kind of handles and works with farmers all across the state. They manage this hang program, and they actually pay farmers to enroll in this hang schedule. And so that's one way. The second way is we've worked with, in the Champlain Valley, I think we've now worked with over 300 landowners just through various components of our projects. And so we've established relationships with them and talk with them. And that's literally just face-to-face interaction. I give a talk also at Shelburne Farms, usually about once a year. I'm giving a talk coming up in, I think, 2 weeks at Shelburne Farms. Different folks come to that. So and Shelburne Farms is a great advocate. They spend a lot of time communicating grassland bird management. And so there's lots of diverse ways. And then I guess finally, Alan Strong at the University of Vermont and Kevin Tolan is here, and folks at VCE, and Roz Renfrew, who now works for Vermont Fish and Wildlife. These are folks also that are involved in this and out communicating with landowners as well. So then the next question is, how do folks in Cuba hunt bobolinks? They are buying mist nets illegally over Amazon. And so they're buying mist nets, which I cannot buy a mist net without showing my permit. Nobody will sell it to me. And so it blows my mind that folks can buy them if I can't buy them. And then what do they do with them? They do 2 things with them. The practice started actually as bird song competitions, where folks would try to trap birds and have them sing in competitions to see who's could sing the loudest, and they would do different like feeding regimens with them to try to get them to sing more and different kinds of treatments. And because of COVID, it's actually changed where they're also now becoming a food source, which is just incredibly sad. And that's I guess the reality of many folks' situation in Cuba, and probably not Cuba alone, right? Probably a number of places in these birds' migration paths. So the next question is, how are the tags attached? They wear them like backpacks, where I have the same kind of stretchy material that kids' jewelry is made with, kids' bracelets, excuse me. I literally buy the material at Michael's, the craft store, and it forms a backpack that it goes around their legs and sits on their back, so it has no connection at all to their wings. It doesn't disrupt or touch their wings at all. It goes under their legs and sits like a little harness. And it's because it's stretchy, it allows them, as they get heavier in the fall, the elastic can stretch and not hurt them or impede them. So it's really been good stuff. So then the next question, how far south in the US do bobolinks nest? They nest in West Virginia, and there is some that nest in Virginia. That is as far south as I know of, in terms of like direct contact that I've had with folks. And they nest way north into Canada, like unbelievably north in Canada. So they've got a pretty massive breeding distribution. All great questions.
A comment from Kevin: grassland organizations have great camaraderie with the central goal of conserving grassland ecosystems. So your success is success for everyone. So.
Absolutely. And I should say that Kevin started earning his chops with the grassland birds working on this project. Mm-hmm. So good for him. His continuing congratulations as a master's student at UVM this fall, studying meadowlarks.
And we'll hear more from Kevin tomorrow evening. Any other questions on your end, Noah?
No more on my end. No. Well, thank you very much for having me.
Yes, it was really interesting to hear what you found out with the tag birds that you tagged at the refuge last year, and we're excited to see what happens with the ones this year. And I think you're definitely going to have to up your grant writing to get some funding to maybe get these satellite tags on some birds. But I think what you're finding out could definitely be beneficial. So
I'd be happy to take you on as an assistant grant writer. So please do, or a fundraiser or any other support system that you want to join in on sounds fantastic to me.
Okay, let me know how I can help.
Thanks, everybody. Appreciate you having me.
Thanks, everybody, for joining us, and we'll see you then. Good night.
Bye-bye. Thank you.